Okay, whew. Welcome to Intro to Backend, Lecture 4. So the core series for Backend goes from 1 to 6, meaning this is the halfway point. So congrats on making it halfway through Intro to Backend, at least the core series. There's also yay. There's also only 3 assignments left, meaning that you're also halfway done with assignments. Not to mention PA 5 and 6, in my opinion, are easier than all the ones you've done so far. So hopefully that is quite a relief, given that the semester is probably picking up pace with all your other classes. So yeah, a few announcements. No PA is due this week, right? PA 3 was already due. So PA 4 will be due next week. So you guys can chill for this week. Everyone's been doing really, really well with assignments. So these are just kind of reminders from last semester, but make sure you remember to spell your routes correctly. There's some mishaps that happen with like not having the /API at the beginning or the trailing slash or whatever it may be. Also, Postman and the test cases file are both very useful. But you kind of both need you need to use both of them in like the respective ways. I saw a lot of people in office hours that were just like spam like running the test cases file and unsure of why their code was messing up, but Postman will tell you exactly where you mess up if you individually test the routes. And then yeah, and then just follow the file submission format and the assignment exactly. I don't think a lot of people had issues with this either, but just to reiterate, make sure you remember to delete your virtual environment, your Pi cache, that kind of thing before you submit, because that's just kind of like mess that we don't need to look at. Cool. So any questions so far? I know fall break was like pretty recent, but also it's like kind of hard to see over there because of the glare, but you can like verbally stop me if you have a question, because I can't really see very well there. Anyway, yeah, let's go over some like review of what we've covered so far, right? So the first thing we talked about is okay, the client server model, right? The server is basically what we're building, right? And anytime we want to communicate with the database, we do it through SQL commands, right? SQL commands will access data for us. And then once we make those SQL commands, the data is then returned to us from the database. And then the next thing we covered last week or last time was relationships, right? We had some very funny Kahoot memes in this lecture, but just to reiterate, some of the relationships we covered were one-to-one, one-to-many, and many-to-many. I don't think I need to explain each of these unless people have questions. No? Okay. And yeah, we use foreign keys to map these relationships, right? Many-to-many has another thing called a join or association table that, you know, kind of like defines the relationship between the two. And you'll actually be using that for PA4. So if you need to refresh, go back to lecture 3. Yeah. Any questions with review? This week will be actually very like light on lecture and demo, so we might actually end early. In which case, Wednesday lecture you'll be able to get out early, so that's also a fun time. But yeah, any questions about what we covered so far? Cool. Okay. So this is a one-to-one relationship, right? We have a user table and we have a profile table. The profile table tells us if a user is like online or away. And the user table just gives us the user's name, right? So in a situation like this, right? If let's say we want to look at the profile status of Jessica, right? We look at her user ID, which is 10, go to the profile table, query 10, and we can see that the value under status is away. So she's away. Same thing goes with me, right? And the vice versa can be done as well. Like the reverse can be done as well. If we want to see, you know, who's this person with ID 30 that's online, we can see that the user ID is 20, and we can see that that's me. So, right, modeling relationships with foreign keys. This is a one-to-many relationship we covered, right? We have an album table and a song table. The only difference between this and a one-to-one relationship is that we can have multiple of the same album ID for, you know, multiple songs to kind of like make that relationship that multiple songs can belong to one album. So if you want to see all the songs that belong to, say, that album, we would look for every song in here with this album ID of 10. And same thing with 20, right? Okay, hopefully that makes sense. Finally, we have the many-to-many relationship. So students and courses, right? Multiple students can be enrolled in one course, and one course can actually, multiple students can be enrolled in one course, and one student can take multiple courses, right? So in a situation like this, instead of representing in the relationship in lists or like storing foreign key in list, we have a join table that kind of combines, like makes pairs of these relationships, right? Of these values. So if you want to see, right, like what courses is student with ID 1 enrolled in, we go to the join table and we can see that it's 1110 and 1998. And we'll go to the courses table and look at the titles or like whatever other details stored in the course table, right? The reverse is possible as well. So if we want to do who is enrolled in 1110, we'll see that 1110 has the ID 1110, and we'll go to the join table and see that, right, student with IDs 1 and 2 are enrolled in 1110, and we'll go back to the student table and see that those students are me and Jessica, right? So this join table basically makes the querying much faster and also much more flexible. And we only have to update one table, which is the advantage of it, as opposed to updating multiple lists and kind of, right, keeping track of that. Okay, any questions? Does that make sense? Oh, did you have a question? Okay, there it is, okay. Okay, cool. And this is kind of an example if you wanted to add me to 1998, you would just add one more row to the join table. Okay, so let's talk about what we're going to talk about this week. So I know, and Jessica knows, that we told you that Python sucks, right? That Python can't be used to store or like handle data, right? So then we went onto SQL, but SQL has its own drawbacks. So what are they, right? The first thing is that SQL is pretty hard to read. SQL, when it's like very like short, so like single line SQL queries, like select all from user, for example, is obviously really easy. But how many of you recall the end of demos? Oh no, the end of Monday lecture for week 3, where I made like a really, really long SQL query and it like didn't work or something. Y'all remember that? Right? So like it's not very like intuitive what it's doing, especially when the SQL query gets like longer and longer. So that's the first thing. The second thing, this isn't always true for a lot of modern SQL libraries, but it used to be true. SQL can be susceptible to vulnerabilities, and I'll tell you in a sec what that means. And also SQL runtime exceptions are not handled well, meaning if your SQL query fails, then SQL has its own version of like erroring out, and Python isn't very good at handling that. So we want to localize everything into our Python environment, right? We want to be basically doing everything in Python. And working only in Python is gonna like modular, make everything we're working with modular. So that's what we're gonna do. We're gonna convert the SQL we're using into Python code. Okay, so here's an example of like a really long SQL query. Okay, in some sense, this is actually really cool what it's doing. But like, can any of you tell me what this is doing? It's kind of a mess, right? I'll give you a sec to stare at it. But yeah, it's kind of hard to interpret. So again, the first drawback, it's a little hard to read, especially when it gets compounded. And then let's talk about vulnerabilities. So there's this thing called SQL injection. Sorry. Have any of you heard of SQL injection? One hand, two hands? Okay, cool. So we'll explain that in a sec. It's actually really cool. But basically you can use a website in like a manipulative way to modify the SQL query that the backend is making. And this allows you to access, resources in the database that would generally not be allowed to be accessed. So let's look at an example, right? Let's say we have this very traditional looking logging screen. We have an email field and a password field. And this is the SQL command that's running behind the scenes. select all from user where the email equals the email that's passed in and password equals the password that's passed in. Pretty standard, right? Does that make sense? We're just checking where the email and the password match, right? So let's pass in an email. We have abc123@cornell.edu. So that value will take on, right? This portion will take on the value abc123@cornell.edu. And say our password is backend, then like the backend will like be inserted into here, right? So if instead, okay, so yeah, in a scenario like this, what happens is, right, if let's say there's no email or there's no user with email abc123@cornell.edu and no user with password backend, then this will be outputted, right? It'll just that command will be equivalent to this: select all from user where false and false, because those queries return false. So this isn't going to return us anything. Now let's say the email exists, then this will be true and false, right? Let's say the email and password combination are correct, then it'd be true and true. But let's think of how we can modify the SQL query so that it can allow us to access things that we're not traditionally allowed to access. So again, whatever you type into email will take take this spot right here, and whatever you type in the password will take this spot right here, right? So if we type in something like this, right, this is actually just an end of a SQL query. If you compare that with this, right, this whole portion just gets replaced with whatever we pass into password. So where password equals XXS, this can be true or false, it doesn't really matter. Or 1 equals 1. 1 equals 1 is true, right? So it will do this end statement first, compress it into a false, and then it'll take an or with a true, so it'll return true. So then it'll just give us all the users. And in SQL syntax, this is a comment. So everything past here is like not detected by the machine. So then what this is basically doing is it's like breaking the login, right? This will evaluate to false and false or true, which will evaluate to false or true, which will evaluate to true. So a lot of, again, modern libraries don't allow you to do this, but in the past, SQL has been susceptible to people just typing in raw SQL code in these password fields and modifying the SQL command directly and allowing you to access unauthorized data. That's just one thing that's cool to note, but not super a concern anymore. But yeah, still nice to cover. Any questions? Yeah. No, SQL does not do this anymore. It is no longer susceptible to this. That would be very concerning. Do y'all have a question or? Okay. Yeah. Okay, so that's the second vulnerability or second drawback. And then the last one was, what was it again? Oh yeah, it's not in Python, so it's like a little hard to work with when it errors out. So our conclusion, what is our workaround around this? Well, our workaround is this thing called an ORM, or object relational mapping. So let's look at what that is, right? So objects in SQL are treated as abstractions. We abstract away from SQL and basically write SQL queries in Python code. So instead of having tables, right, or like models and entries within a table, we have classes and objects like you all are familiar with, right? So like a user table would instead be a user class and user objects of that class, right? So yeah, this is great because it basically runs SQL commands under the hood, but it's in a language we're all more familiar with and in like kind of like a format, right? Class object format that we're also more familiar with. So that's what we're going to be doing this week, is going to be translating all the SQL stuff we learned into ORMs. So this is an ORM, right? So we have a user table with ID, name, and age, which are the 3 fields. And instead in the ORM, it would be class user, right? So like class and objects. And then fields within the class, so like ID, name, and age. And you can specify the data type just like you can in SQL. But this time it's in Python, so it's like easier for y'all to work with. So the framework, right, or the library we're going to be using for this ORM is called SQL Alchemy. It's a very popular ORM for Python. It's also very easy to use because it's, the keywords used directly translate to the keywords in SQL. And it's amazing because it integrates seemingly with Flask. So it's like, it's very easy to use along with Flask is basically what we're trying to get here. Okay, make sense? So what are some benefits of ORM, right? Well, obviously the first one is that it's more readable and it's in a language we're more familiar with, right? I can't emphasize this enough. It's just we're more familiar with something like an ORM as opposed to raw SQL. And the cool thing is that there's actually ORMs in multiple different languages too. So if say you're more familiar with like Java, then maybe there's like a framework in Java that's an ORM. So I personally use an ORM in TypeScript on app dev. Yeah, multiple ORMs, very cool to use. It's also SQL free, so this means that we don't have to be typing any raw SQL code. A lot of ORMs are compatible with a lot of types of databases. So in this class, we use SQLite, but when you go on to work on bigger projects, maybe you use something like Postgres or Mongo, and a lot of these ORMs are compatible with those as well. And yeah, it's secure against SQL vulnerability. But again, most SQL libraries are now as well, so that's not like the biggest difference. As for ORM drawbacks, the biggest thing is that it's a bit slower. So because it's running SQL under the hood, it first converts Python code into SQL and then runs it. So obviously that's a bit slower than like just running direct SQL code, right? That's the first thing. The second thing is that it usually increases application code, meaning it increases the amount of text you have to write, even though it's more legible. Rather than select all from users, it would be a little bit more code to type. I guess another thing is like it abstracts away from the fundamentals of SQL. So if you're not familiar with SQL and you want to learn SQL, maybe you shouldn't be using an ORM. And yeah, since it's so abstract and it's written in Python, it could be, it could lead to some misuse because it's so simplified, but we will hopefully teach you not to do that. Yeah, the biggest thing is that it's slower. Okay, and this is just something that I want to cover real quick, just so you guys know the distinction and like proper architecture of a backend. What should be stored in app.py? So app.py, right, should connect the server to the client. So this is like the server actually like accepting requests, right? The server actually accepting requests is defined in app.py, just like in the endpoints, right? And it also defines all the routes and the responses. So this you're all familiar with. And then the last thing that's really important, this is the most important part, is that it handles all logic and operations. So it handles all kind of like calculations in app.py. So for PA2, y'all recall with like, transferring money or whatever, like withdrawing or like depositing money or yeah, whatever the difference is. You want to handle that in app.py and not db.py. And I think I mentioned this once like briefly as well, but db.py connects the server to the database, defines the tables and the columns, and basically just does single line SQL operations, and you pick and choose which ones to use from app.py. So that's a distinction in this app.py and db.py architecture that is going to help you a lot if you practice, especially for the hack challenge where your project's going to be a bit bigger. Okay, does that make sense? Any questions? About ORMs? And yeah, this is just review from last time, so let's skip over this. Okay, so that's actually it for lecture. Again, very short. The main takeaway is that we're going to be converting SQL to Python code in a library called SQL Alchemy. And that's what Jessica is going to be doing. So yeah. Okay. And all the files in here. This is DB Python demo 3.
Oh, okay. Then where's demo 4?
Demo 4.
Oh, sorry.
Demo 4 is in here.
Oh, okay. Wait. Oh, okay, got you. Okay. All right. Hi, everybody. Today we're going to be talking about abstractions. So we're going to be continuing off of our tasks and subtasks model from demo 3. So just to start off, reiterating what an ORM will be using. Today, we're going to be using a tool called SQL Alchemy. SQL Alchemy, it's a weird word. But basically that allows us to translate our SQL code into like more understandable Python code. So you can follow along with today's demo. Can everybody like download the source code from the starter in demo 4? Yeah. Everybody ready or yes? Okay, so starting off as per usual, creating our virtual environment. So wait. Okay, so all right, so start making a virtual environment. So oh yeah, so oh my gosh. It's been a while. Okay. So we create our virtual environment called them. That's the folder. And now we're going to activate our virtual environment. So oh, wait,
No, you're in the right folder.
oh, okay, yeah.
It's already activated.
Oh, it is?
Yeah.
Oh, why is it? Okay, sorry. Oh, not used to the Windows. Okay, I'm not used to the Mac. Okay, so now we're gonna pip install our requirements so we can get started. Okay, awesome. Now let's get our server running. Okay, cool. So virtual environment created, everything's installed, our server's running. Now let's start some code. So just looking at our db.py from last time, looking at our task table, we have our ID, description, and our Boolean, like done, done, not done. And then moving on, we have our subtasks, which is like every task, every subtask associated with a task. So again, we have our ID description and then the associated task ID for that subtask. So then starting off in our fresh file for this demo, so just to iterate what's in our app.py file, our standard like file name to-do.db, our db file name to-do.db, and then our app using Flask, and then just like go over what lines 11 to 13 means. So basically it's SQL Alchemy database URI. It's saying what I guess like what's it's being used, SQLite, and then the file name it's taking in. So it's taking in DB file name, which is to-do.db. So it's associating the database with what we're working on right now. And then like track modifications, that's false, just you need to have that. And then SQL Alchemy Echo, what that means is that it basically tells us which SQL code is actually running under the hood. So that's something pretty cool to consider. And then here we have all our routes. And then in our DB file, we're going to work on implementing our classes. We're in the past with SQL Alchemy, we're used to working with tables, but now we're going to switch over to working with classes. So let me put this to the side. And then, oh, yeah. Oh. Sorry, guys, this is Shingo's computer, not the most familiar. So okay, yeah, so we're going to start off with defining our classes for our tasks and subtasks. So starting off, we're going to, oh, this is, oh, oops, wrong demo. Okay. Okay. Okay, right. So starting off with our first class. So class, we're going to name it our first class, we're going to name it task. And then it's going to take in our db.model. So basically the model feature, it just tells us like, this is kind of like the blueprint for the class that we're defining. And then let's write some quick documentation for what we're defining. So our class task, that's going to, oh,
I keep forgetting.
okay, awesome. All right, so writing some quick documentation for our class task. That's going to have has a one-to-many relationship. Ooh, one-to-many relationship with subtask, and okay, yeah. And then, so starting off with defining our class task in SQL Alchemy, that's what we're using at the top. You can see that in line 1. And just to reiterate, so SQL Alchemy is basically a tool that the ORM, it's the tool that we use to like perform ORM features essentially. So we are going to define our table name, and then the table name, it's going to be a string. It's just going to be simply task, and it's singular, something to note. Then we're going to have our basic ID. And so since we're back to using like Python syntax, it's just going to be db.column. So think of it kind of like as like a column in your database. And then the type of our ID is going to be db.integer. So we're back to like standard Python types. And then this is going to be the primary key of our table. So primary key equals true. And auto increment equals true. Auto increment. Oh. Okay, moving on. So looking at what we had last week, 2 weeks ago, for our task model, we had the ID description done. Oh, this is the subtask, my bad. Okay. Yeah, ID description done. So we're gonna do the same thing with SQL Alchemy. So we're gonna have again our description, and then it's gonna yeah. Description, same thing, it's gonna be another column. And then it's going to be the type of our description. It's going to be a string. And then we're going to set nullable to be equal to false. So essentially, it has to be like each task has to have its own description. And then quickly doing done. Again, a DB column, and that's going to be a Boolean this time. And then nullable again is going to be equal to false. And then, oh, yeah.
Comment something.
Oh, yeah, yeah. So subtask. Okay. All right, so moving on. So this is basically our like general setup for our class task. So then moving on, as we are familiar with Python classes, we're going to define our init function. So our init function takes in something, as we know, called self, and it also takes in something called quarks, which is a really weird word. So basically, quarks stands for keyword arguments, and it essentially is a dictionary. And then you can it like cuts down on time in creating that dictionary. So I'll quickly do a demo in terminal. Oh, okay, which one is it? Okay. So many. Okay. Okay. Okay, awesome.
And you can command plus because it's like a little small.
Oh. Okay. So quick demos to like what keyword arguments are. We're going to have basically what you send in is going to be like, say you have like demo name. Oh my gosh, name. Oh my gosh. Okay. Name equals Jessica. Age equals 20. Yeah. Oh.
There's no quotes there. There's not supposed to be quotes
there. There isn't? Oh.
But for age and
Oh, my bad. Okay. Ignore the quotes. My bad. Okay. Okay. Yeah. So what keyword, looking at the definition at the top, so def demo takes in keyword arguments and then it prints it out. So keyword arguments, think of that as like your dictionary, and then it sets like the initial variable to be the key, and then what it's assigned to be the value. So as you can see, the output in our demo, it's going to have the key name, and then the variable the value Jessica, and then the key age, and then the value 20. So then applying this to our initialization of our task class, we're then going to have, so self.description for our task is going to be equal to quargs.get, because quargs is a dictionary, so think of it that way. So we're calling a get function within our dictionary. So quarks.get our description. And then the cool thing about this is if like say a description is not given, we can just set that to be an empty string. So the first argument is going to be the key that you're looking for. The second argument is like the default key to set it if a description is not given. And then repeating the same, I guess, logic for our done, it's going to be quarks.get done. And then we're going to set our default value for done to be false, aka our task has not been done as yet. Okay, awesome. Does anybody have any questions thus far? Okay, cool. So moving on to our serialize function. So right now, our this is Python code in our database file, and essentially we want to then convert it to something more readable for our something more readable to be used later on. So now we're going to define a serialize function, which essentially changes our task object into a more readable, understandable dictionary, which is what we have been accustomed to in the past couple of weeks. So our def serialize, and then that takes in self. So again, writing a little bit of documentation. So our serialize function just serializes a task object. Okay, cool. Oh, yeah, sorry. So documentation for init function, it just creates a task. Okay. Okay, cool. So now what we want to do is basically return the dictionary format of the task object that we just created. So we're simply going to return, setting up our dictionary. We're going to have our ID to be self.id. So like self is like, for those of you who took 1110, self is like the literal task object that we're currently dealing with. So like we're doing self.id, so it's the ID associated with that task object. So description is going to be self.description, and then done is now done is going to be self.done. Okay, so does anybody have any questions thus far? Okay, cool. So then moving on to our seeing our code in our I guess like moving on to like linking this code in our DB to our app.py. Here we're back to our initial setup. So actually, let me have this to the side in case anybody's still using it. Okay, so our initial setup. So now we initialize our app, DB init app, and then we're going to have our generalized response formats. Some of you might have seen this in the past, but just to I guess read it. This is like a standard like cookie cutter response format for success responses and failure responses. So you send in your data and you send in your code. So code equals 200. Code equals 200 means again that 200 is going to be the default code for a success response. And then later on 400 is going to be our default code for our failure response. So then using this, seeing this like in a real life example. Okay, here, so our function def print code equals 200, and that's just going to print our given code. So say we call print code and we don't send in everything, 200 is initially like immediately printed, no questions asked. And then say we do print code and then we actually send in a code, print code 201, that's going to print 201. So just to iterate, when you have like code equals a value or just like x equals a value in your function parentheses as value sent in your parameter in your function header, that is the default value for that given parameter for a function. Okay, so that's just to I guess cover like failure responses and success responses. It makes your life a lot easier when you're I guess returning success responses at the end of your app.py routes. So now we're going to work on getting the tasks we've got thus far. So we're then gonna do, so we have our, oh wait, no. We're gonna import our, from our database, we're gonna import our task object. So we know, from our tasks, we're gonna get our tasks. So we're gonna implement the input for getting all our tasks now. So we're gonna have an empty list of our tasks. And then now we're going to get all our task objects. So, and we're going to essentially loop through that. So for task and in order to get all your task objects, we're going to call a, basically the SQL alchemy of equivalent of select star from task table. It's going to be task, which is like the class name dot query dot all. So basically this is just going to return all of the task objects in that given class objects in that given class. Does that make sense to everybody? Okay, awesome. So now we're going to then tasks, which is our list of tasks, dot append, and then we're gonna append our serialized task object because we need to put it into a format that is now understood. So task dot serialize. So we're going to call our serialize function on each of the task objects in task.queryAll. Is everybody following? Okay, great. Then we're simply just going to return a success response of our tasks. So tasks is going to be set to our given tasks. So now we can try set this up. So let's go. Oh, yeah. Okay. So let's go to Postman and start testing out what we just implemented. Our server should be running. So let's make a new collection. Ooh, how do I rename this? Okay, rename demo 4. Okay, so I do not want to do that. Okay, so let's add a request. We're gonna get all tasks. It's gonna be a get request. We're gonna get our, what's the URL? Oh, okay. Yeah, okay, let's just try that. Okay, so this is a route that we're supposed to get our tasks from. My server stopped, my bad. Okay. Oh. Oh, my bad. Okay. Let's try this again. Yeah, so let's run our terminal or run our server. Python app.py. Okay. Oh. Okay, server's running. Let's go. Let's get all our tasks. Oh. Oh my.
That's fine.
Oh, there we go. All right. So here we have all our tasks that we have not created or created at all, but still, that's what's responded. That's what's sent back. We're sent back an empty list because we have not gotten any tasks thus far. So now we're gonna clean up lines 40 to 42 just a little bit. So basically there's a way to do like a condensed for loop. I can show this in like a demo again. So, okay, where's the one that I made? Okay, here we go. So looking at this example, what we're going to do is that we have our function definition, add 1, and that basically adds a number to our given array. And then our given array for this example is going to be called demo plus 1. So it's just like a list 1, 2, 3. So then if we look at this for x in range, the length of demo plus 1. Demo plus 1 at position n is equal to demo add 1 demo plus 1 at position n. Okay, so okay. And for x, okay, my bad. Okay, let me just do this again. So for x in range, this should be n, my bad. This should be x, my bad. Okay. Yeah, okay. Oh, and then I want to now print demo plus 1. Okay, awesome. So as we see here, originally demo plus 1 was 1, 2, 3. And then we ran our function, we looped over our array demo plus 1, and we added 1 to each item in our list. So then we got 2, 3, 4. But there's another simple way to do this. That's simply just this, like using basically a condensed for loop. So it's just going to be add 1 at the value n for n in demo plus 1. Yeah. And then, okay, perfect. So as we see, it does the same thing. So then it goes from 2, 3, 4 to 3, 4, 5. So add 1 n. So that's the value that's being sent in for n in demo plus 1. So for each value in demo plus 1, you're applying the function add 1. Does that make sense to everybody? Oh, yeah. Pardon? Why does it print? Why does it print out 3, 4, 5? Yeah. Oh, that's like what's being returned. It's not printing it out. It's just we're calling this function and that's what's being returned. I think it's because like in the example before, nothing was being printed. I was executing a for loop on that input, and then I had to print out the value. But here I'm actually calling a function, and then it's just returning that value, which is why it's being displayed on the screen. So I think in one case it's being printed, in the other case it's just simply being returned. Does that make sense?
No.
Yeah. So the same way.
If it has a return value, it'll just print it on the terminal.
Yeah. Great. Okay, awesome. So then now applying this to our I guess like task our app.py task thing, task get task thing. Okay, awesome. All right. So instead of like a list task and then looping through our tasks, we can just simply just do a more like condensed version. So tasks equals task dot serialize. Oh my bad. Task dot serialize. Oh, I cannot spell. Serialize for task in task.query.all. So we're essentially doing the exact same thing, but in like a more simple form, and we're just like taking this out. So we're applying the serialize function to each of the tasks in task.query.all, and then we're returning that in our JSON, in our success response, and then that should do the same thing. Okay, so I think that's all the time we have for demo today. Does anybody have any last questions? Oh, yes. Okay, yeah, great question. So essentially when you, where's your VS Code? Oh, awesome. Okay. So when you, so task.query.all, that's going to return a Python object, right? And essentially you need to turn that Python object into a format that's appropriate for our for the task, for our success response, for the Postman queries, to deal with our backend. So essentially you're changing that task.object into a dictionary response, which is then more appropriate for what we want to then do with our database. So for each task object, you're putting that into a valid format. Does that make sense for everybody? So it's just it's basically just proper formatting for what we're trying to achieve. Great. Any other questions? Okay, awesome. Kahoot time. Look at go.
Yeah, I mean, you do it.
Yeah.
Sure.